Let's start here with problem number 2 in the textbook. This is similar to problem number 1 in MML. Let's give it a try here. What we're asked to do is find the number in the union given the individual numbers and the intersection. So look at the information we're given. We're given two sets with the union, the intersection, and the individual sets. We just happen to have a formula that has all of that in it. So let's write that formula. So here's our formula. The number in the union is equal to the individual numbers minus the number that's in common. So let's start here. The number in the union, well, that's what we're looking for. So let's write that. We will have the number in the union of S and T. That's even the number in S, which is 17. Number in T, that's 13, minus the intersection, that's 9. So we'll have the number in S union T being, now, 17 and 13 is 30, so we might even write that 30 minus 9, so we'll get the number of elements in the union is equal to 21. You know what might be a good idea here is let's draw a Venn diagram. I'm going to draw my universal set here, and I'm going to draw my set S and my set T. And now I'm going to look to see how many elements I've got in each position. So I'm going to look at from the innermost up. Now here's what this says. This one says that the number in the intersection, now here's the intersection right here, that there's 9 elements there. All right, so we'll put a 9 in here. Then continuing on, from this information, it says that there's 13 elements in T. And if I go to T here, there's 13 in there, but I've already counted for 9. So how many are in this region right here? Well, 13 altogether. I've already accounted for 9, so this must be a 4. And the same type of idea for S. If I look up here, S has a total of 17 elements in it. And here's S. We've already counted for 9. So over in this region right here, since there's 17 altogether, there must be 8 right there. And then if I add up these elements, how many do we have altogether in the union? I've got 8 and 9 is 17, and 4 more. That's our 21. So I can do this problem using this formula, or I can do it using that Venn diagram. Either way works. All right, in problem number 4 here, we're supposed to find the number in the intersection. In the last problem, we found the number in the union. Now we're going to find the number in the intersection given this information here. And once again, we can use our formula. So I'll write that. And let's fill in the numbers now. So the number in the union, that's given right here. That's a 15. We can write that equals the number in S. The number in S, that's a 4. So we can put a 4 in here. Plus the number in T. Well, the number in T is over here. That's a 12. Minus the number in the intersection, which is still unknown to us. Now, let's see where we are. This is 15 is equal to 16 minus the number in the intersection. And if we subtract this 16 from both sides, we will get negative 1 equals negative, or the opposite of S intersect T. And then multiplying or dividing both sides by negative 1, we will get what we're looking for. The number of elements in S intersect T is 1. Now in problem number 6, we're asked to find the number in this particular set, the number in T, given we know the number in S, the number in the intersection, and the number in the union. So again, we'll start by writing our formula. So here's our formula, and let's just start substituting in values. So first, the number in the union, that's up here, that's the 14. So let's put a 14 there. The number in S, well, the number in S, that's up at the top here. That's a 14 also. So we get a 14 here. Plus the number in T, that's what we're looking for, so we'll just represent it, minus the number in the intersection. And the intersection, we're told, has 6 elements in it. So minus 6. Now here's what we are. 14 equals, and then this 14 minus 6, that's an 8, plus the number in T. And if we subtract that 8 from both sides, we'll have 6. It's equal to the number of elements in T, and that's what we're looking for.